Hello candidate, welcome to my math class. I'm Teacher Adam. Today we are continuing with the same unit, laws of indices, and today we are going to review the opening of brackets. I know last time we reviewed this law. It was about when you open the bracket of powers. For example, you have AB power n. Then we said when you have this case, it will be A power n, b power n. And there was this one also, we say when it's a, b power m, and n, we reviewed this one too. We say it will be a power n, b power mn. Okay, so with that, in our previous class, ended on only single term. So, dear candidate, I ended on only one single term. Our single term was basically this one. It was a number, let's say b power m outside power n. Therefore, we had b mn. In such a way, you have 3 power 4, and then outside you have 2. Then we said, in this case, when you're opening the powers of indices, you keep the base the same, which the base is the number, bottom number, and then you multiply the powers. 4.2, you keep the 3, then 4 times 2 is 8, say power 8. Your answer becomes 3 power 8. That's what we reviewed. So in our today's math class is when you have two terms. Like for example, you have two bases. You have A and B, and then you have a power here on top, then power n. What do? In that case, you basically, each single term inside multiply by n. So in that case, you say A power n and B power mn. If you do that, let's say for instance, you have 3x power 4 and then outside power 2. What do? You say 3 power 2 and then x 4.2. 3 power 2, what's 3 power 2? 3 power 2 is 9, and then x 4 times 2 is 8. You get 9x power 8. Then you have, let's say, 4x power 6, then outside power 3. What do? You say 4 power 3 times x, 6 times 3. What do you get? 4 power 3. 4 power 3 is 4 times 4 times 4. That's 64. Then x power 18. You get that. So what means when you have numbers inside the bracket, let's say for example 6x power 2, and then you have a power on top. This power is you raise any single term inside the bracket with a power. In that word, if you break it, it will be 6 power 3 dot x2 times 3. This is what you do. And then you do separately 6 power 3. What's 6 power 3? That's 6 times 6 times 6. And then x, simpler, it's power 2. So you say 2 times 3 is x power 6, and you get your answer. So with this law, that's what you basically need to do. We are also going to review about when you have fractional indices. So you say fractional indices, the law of indices. So what do we need to know about this? So with the fractional indices, it can be this way. Let's say you have a fraction. Let's say you have a over b, and then you have a power outside. Now we understand a over b is a rational, it's something that can be written as a fraction. Now if we want to open a bracket, in this case we say is the same as a power n over b power n. How? Let's go, dear candidate. So you have, let's say for instance, you have 1 out of 4, and then bracket power 2. What does this mean? This means 1 power 2 over 4 power 2. What does you get? What's 1 power 2? It's 1 times 1. It's not 1 times 2. Most candidates, they always make that mistake. So in that case, it's 1 times 1, you get 1. 4 times 4, you get 16. 1 out of 16 becomes your answer. Very good. Then if you have, let's say 2 out of 5 power 2, what does that mean? It means 2 power 2 over 5 squared. Very good. 2 times 2, what's 2 times 2? 2 times 2 is 4. And then 5 times 5, which is 5 squared, you get 25. This becomes your answer. Very good. Then you have, let's say you have 3 out of 9 squared. What do you do in that case? In this case, you say the same as 3 squared over 9 squared. Correct. What do you get in that case? 3 squared is 3 times 3, which is 9, over 9 squared is 81. 9 times 9. And you get your answer. Very good. So we understand about that when we have a fraction. And then we also reviewed, and maybe I can go once more on the same we had this. You have a power negative 1. We said any number power negative 1 is the same as the fraction of that number. It's just 1 divided by the number given. So in this case, it will be 1 out of a. How? This is the same as we know this is the same as inverse. If you did function, if you learned function, I taught you in the previous unit, I taught you about function. This is the same as the inverse of a, means the opposite of a, 1 out of a. So, and you say if you take the inverse of a number times the number, you should be able to get 1. They simplify themselves both to get 1. So in that case, let's say for example, you have 2 power negative 1. It's the same as the fraction of the number. It's 1 over 2. So if you have 3 power negative 1, is the same as 1 out of 3. That's it. Let's say for example, you have 3 power negative 2. So this is a new concept. So in this case, 3 power negative 2, what does it mean? In other words, if you say it's 3 power negative 2, we know automatically 3 is what we call the base. And then negative 2 is what we call the power, or some book refer to as exponent. What we know now, so we have 3 power negative 2 and we have 3. This is the base. 3 is the base. So we have to refer back and expand this. We'll come to understand that 3 power negative 2 is the same as 3 power negative 1 times 3 power negative 1. When you're multiplying numbers with the same base, you keep the base the same. And do what to the powers? We say, and we add the powers. So we keep the base as 3, and we say negative 1 plus negative 1. And laws of integers here you apply. Negative 1 plus negative 1, what do you get? Very simple, candidate. Is the same as 3 power negative 2. Now we understand. But now let's go back to our understanding of inverse. 3 power negative 2 is the same as 1 out of 3 power 2. And then that's it, the same as 1 out of 9. This becomes your answer. The same as if you are asked about 5 power negative 2. What does it mean? It's the same as 5 power negative 1 times 5 power negative 1. Then this, what's 1 out negative 5 power negative 1 is the same as 1 out of 5. And what's 5 power negative 1 is the same as 1 out of 5. Then you do simpler. 1 times 1, 1. 5 times 5 is 25. If this concept you don't understand, okay, that's fine. Then we go now to the fractional indices. When you're given fraction, you still apply the same powers of adding. Whether, for example, let's say in fractional indices, it means those our powers, instead of having whole numbers, you have indices. So fractional indices. So if you are having fractional indices, let's say for example you have a power half times a power a half. What do? In that case, these are numbers with the same base. If they're numbers with the same base, you keep the base the same and you add the powers and you get your a power 1, which is the same as a. So in that case, if you're having let's say if you're having x power 1 out of 3 times x power 1 out of 3, what do? You keep the base the same, x, and then add up to the powers. So it's x power 2 over 3 and you get your answer. Very good. Now, what we need to understand, we also need to understand other fractional indices. For example, when you have a number, let's say a square root of a, this can also be represented as a power a half. So if you're having, let's say, square root of 9, this can be represented as 9 power a half. How do we solve without the use of calculator? How do we solve this without the use of calculator? For example, now we have a fractional. We say 9 square root of 9 is the same as 9 power half. If the examiners want you to solve without the use of calculator, it's very simple. So break this into the power form. It will be 3 power 2, and then out of bracket a half. And then what do you do to the power? You say 3. How do you open the brackets? We open brackets by multiplying. So we say 2 times a half. A half of 2 obviously is 1. So 3 power 1 is the same as 3. That's it. You need to understand that as a candidate. Okay, another concept that we need to understand is when a number is cube root, let's say cube root 27. How can this be represented? We say this can be represented as 27 power 1 over 3 mathematically. And then what do? Without the use of calculator, change this 27 into the power. You write it as a form of power, but use this one as a smaller unit, 3. So it will be the same as 27 is the same as 3 power 3. 3 times 3, 9. 9 times 3, 27. 3 power 3, then everything power 1 over 3. How do you open the powers? You keep the base the same and multiply the powers. So a third of 3 obviously is 3 power 1. Then you get your answer as 3. That's it. So you need also to understand that. But now, like for example, if you have a question like 3 over 4 and then something like that, like it's the 3/4 root 27. What do? The same case here. Don't confuse. Just say 27 power is the same as 27 power 3 over 4. And then apply this. You can solve it using the root. You just need to understand. So even this kind of questions, it can come there. But if they say without the use of calculator, you just solve it. If it's with the use of calculator, you just apply it in the calculator formula and you get your answer. Very good. Now, we are going to have some different, let's say, like for example, you say this shows that any root of a number can be written using fractional indices. Let's say, for example, you have x power 1 over m. This can be written as m root x. Yeah, so the m is on top there. So the fractional, like for example, you have, let's say 25 power 1 over 5. And then this can be written as 5th root of 25. That's it. This one can be written as 5th root of 25. All right. Now we understand that. Rewrite using root sign. So for example, I can give you some exercise. Rewrite using, so you have to rewrite using root signs. How do we do in this case? This is very simple. You can say, if you have y power a half, this is the same as square root of y. That's it. That's simple. Then if you're having x power 1 over 5, this is the same as this is simple. 5th root of x. You write that. And if you have x 1 over y, what's this? It's the same as y root x. So understand, if you understand this, all these are laws that can help you to solve different questions in this unit. So I think majority of the questions you'll be examined in that angle. So, and sometimes you have to deal with those kind of questions, especially when they are a lot. And there are some questions that they say, I can see here we have, like for example, when you're told to work out. If you're told to work out, or when you're dealing with non-unit fractions, what are we supposed to do? So it's the same. We still apply the same concept. We apply the same concept. So the laws of indices, just need to memorize the laws and then know how to apply them. And then analyze any question. So any question that we have from this chapter, we analyze it, we are able to solve. For example, let's say you have x power 1 over 3 and then outside 2. This is simple. Very simple. What do you do in this case? This is the same as we say when opening the brackets of powers, you multiply them. So a third times 2. A third times 2 is the same as 2/3. So to represent this is the same as cube root x, then squared. That's it. You get your answer. You have y power a quarter, then outside is 3. What does this mean? This means that is y power 3/4. So how do we write it in terms of the square root? This is the same as fourth root y, then everything cubed. That's it. If you understand that philosophy, you will automatically know how to solve majority of the questions in this angle. And let's say, for example, if you have x power 2/3, this can be written as 3 the cube root x, then everything squared. I hope you have understood in that angle. Let's say you have y power 3/4. This one can be written as 4th root y, then everything cubed. In general terms, x power m/n. This can be simplified into, so we say x power m/n. This is the same as x m times 1/n. So that's what you should understand. And therefore this one is broken as, this power n is what we have it as a fraction. And then this one, x, this becomes what? Your power. The m becomes the power, but this one, the n is the 4th root, is in the sign for square root. Now, work out the value of, we're going to have different examples. 27 power 2/3 is same as 3 power 3, then out of brackets 2/3. What do you get? 3 power 3 solve. We open the bracket, so 3 times 2/3. When you do that, first of all, how do you represent this in the formula that we learned there? So this is the same as, we said, the fraction. This one, if you break it, is the same as 27 2 times 1/3. We understand. So we say this one is the n. This one is the n. Therefore, it becomes like the cube root, cube root 27, then everything squared. Are we together? If we have to apply our fractional understanding, we're changing the base. We open the bracket. What do we get? What's 3? So we say that's 3 times 2 is 6. Divide by 3, you get 2. So it's the same as 3 power 2, which is 9. Let's see with that understanding. The cube root of 27 is 3. So 3 squared is 9. Correct. Now we have understood. You have, what if B, example B, you have, work out the value of 25 power 1.5. Very good. So 25 is the same as 25 power 1.5. It means 1.5. So it means 1, it's 1 times a half. That's what we have. A half is 0.5. So in this case, is the same as 25 power 3/2. Correct. Then when you break this, 25 power 3/2 is the same as 25, we say 3 times a half. That's it. So if you go back to the law, a half is the same as square root. A half is the same as square root. So square root of 25, and then everything cubed. All right. So what's square root of 25? Square root of 25 is 5. 5 cubed is 125. 5 times 5 times 5. Correct. Sometimes you can be asked to find the value of the powers that produces a given result. And then what do we need to know? So an equation that requires you to find the exponent is called an exponential equation. So sometimes we have exponential equations, and then we're told to find the value of y, like finding the value, missing value. Like you're given an exponential equation. Let's say you're given an exponential equation in this form. They say if 2 power x is equal to 128, find the value of x. Correct. So what do we do in that case? So our idea, we need to understand everything in one form. For example, we need to understand when you have a base 2 power x, how can we equate so that any number that we put here should be equal to 128. So there is one for testing, and there is one that it's called trial, based on trial. Like for example, if you say 2 power 4, you check. You start with 2 power 0, 2 power 1, 2 power 2, 2 power 3, until the number that is close to your answer. For example, if you say 2 power 7, if you say 2 power 7, will you be able to get, like, it's 2 times 2 times 2 times 2, 1, 2, 3, 4, times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 64 times 2, 128. So this is basically on testing. If you test, you get your answer correctly. Yeah, and actually another way, let's say if you have 128, divide by 2, what do you get? 64. 2 divided by 64, you get 32. 2, 16. 2, 8. 2, 4. 2, 2. Then another method, apart from the trial method, you can change the bigger number into the smaller number. Write it in terms of base and powers. In terms of base and powers. So this will be 2 power x is equal to 2 power 7. So if the bases are the same, what do? That's another law. If the bases are equal, also the exponents are equal. That's another approach. Correct. Now, dear candidate, we are done with the topic laws of indices. I'm going to solve out some question. The first question, evaluate 8 power 1 over 3. This is the same as 2 power 3 and then 1 over 3, because you change 8 as right in terms of powers. It's 2, 4, 2, 2. So you have 2 times 2 times 2. 2 times 2 times 2, which is the same as 2 power 3. Correct. So 2 power 3 times a third. So that means 2 power 1, which is 2. Correct. And then you have another number. It's 32 power 1 over 5. 32 power 1 over 5. This is the same as 2 power 5, because 2 power 4 is 16. 16 times 2 is 32. So 2 power 5, then outside power 1 over 5. So if you multiply, you get 2. Your answer becomes 2. That's it. Another example I can do in this unit. You have, let's say, they say find the value of x of this equation. You have 2 power x is equal to 64. This is very simple. In this case, you have the trial method, or change 64 in terms of 2. Write it in terms of base and powers. So 64 is the same as 2 power 6. So 2 power x is equal to 2 power 6. If the bases are the same, also the exponents are equal. So the answer is x is equal to power 6. Correct. You might have different scenarios. Let's say they say solve, let's say, x power a third, let's say 2 power x. They say 2 power negative x is the same as 1 over 64. You should not be shocked with this. Write it in the same form. You can say, change it, because the base here is 2. Also make the base the same. So you have 2 power x is the same as 1 over 2 power 6. Then write it as in the same term, because this is a number with its base, with a negative base. So also write this number as a negative base. So it will be 2 power negative x is the same as 2 negative 6. Then, since the bases are the same, negative x is equal to negative 6. Equate the exponent. So negative x is equal to negative 6. Divide by negative 1. So x is equal to 6. Correct. You might also have different form of question. Let's say they have 16 power x is equal to 8. What's 16 and what's 8? Change it in the same form. Simpler. You say 2 power 4 x is the same as, because 2 times 2 times 2 times 2, and then 2 power 3. The same base, 2 power 2, then 4. So you say 4x, you equate 4x is equal to 3. Divide by 4, divide by 4. So x is the same as 3 over 4. Correct. So that's majority of the questions that might come in this chapter. But I'll review this question that came in May. It was May-June 2011 mathematics paper 2. Simplify a 32x power 8 divided by 8x power 32. What do? We say you can divide. When you're given numbers, divide the way they look like. 32 divided by 8. What's 32 divided by 8? Is 4. 32 divided by 8. It's 4. X power 8. So we have x power 8 divided by x power 32. When you multiply numbers with the same base, what do you do to the powers? You take away. So you keep the base the same and take away the powers. So your answer is 8 minus 32 is minus 24. So times x power minus 24. So your answer will be 4x power negative 24, which can be written as 4 over x power 24. Correct. That's the answer. The B part, they say x cubed over 64 power 2 over 3. What did we say about the fractional powers? We say you can multiply them with the same. So this is the same as x. You multiply with the numerator, x power 3 times 2 over 3, divide by 64 power 2 over 3. Solve it as separate. Then what do you do on the numerator? 2/3 of 3 is 2. So you have x power 2 divided by what 64, that one. So it means this one is the same as 4 power 3 and then 2/3, which is the same as 4 power 2. So your answer will be x power